An introduction to labeling triangles and the trig ratios. Trigonometry allows us to find unknown sides and angles in right-angled triangles. Unlike Pythagoras, it uses the angles as well as the sides. So we need to learn more about labeling right-angled triangles. We already know that the hypotenuse is the side opposite the right angle. It's the longest side because it's opposite the largest angle. So we can label the hypotenuse in both these triangles. We can label it with hypotenuse or just with H. Now you'll see that both these triangles have an angle marked. My first one has this symbol. It's like a circle with a line through it. This symbol is theta, and it means the angle. So it's often used for an unknown angle, and it means the angle that we care about. That's because when we label the short sides of right-angled triangles, we label them compared to where an angle is, not the right angle, but one of the others. So theta is the angle that we care about in the first triangle, and the 23 degrees is the one we care about in the second one. The easiest one of the short sides to label is the opposite. It's opposite the angle that we care about. It's the line that doesn't touch the angle that we've got marked. So on our other triangle, the opposite is always one of the sides that touches the right angle, one of the short sides, but it's the one that doesn't touch the angle that we've got marked. And then we've got the hypotenuse and the opposite labeled. The only other side is the short side that is next to. It's touching the angle that we care about, and that uses an old-fashioned word for next to, which is adjacent. So we label our sides the opposite, hypotenuse, and adjacent. Now the hypotenuse is always the same in a right-angled triangle. It's always the longest side. But if I drew that same triangle and said, actually now I care about the angle up here, we never consider the right angle to be the one that we're taking as a reference, but if I changed the angle that we care about, this would still be the hypotenuse, but now the opposite and the adjacent would have changed sides. So they're labeled opposite and adjacent just based on which angle we're worried about. So our first skill is we must be able to label the triangle. The second thing we need to know is that trigonometry is actually about similar triangles. And you'll remember in similar triangles we keep finding ratios of sides. So the ratio in my example of the two short sides is 3 divided by 4. I could have done a ratio of 3 divided by 5 or 4 divided by 5, because we do keep finding ratios of sides inside triangles, and that's very important. So let's just label the sides of this triangle. Opposite the right angle is the hypotenuse. Opposite the angle we care about, which is 37 degrees. Side 3 is the opposite, and so side 4 must be the adjacent. The 3 sides mean there's 3 different ratios we could have. I could have done 3 divided by 4, opposite divided by adjacent, or I could have done 3 divided by 5, opposite divided by hypotenuse. or adjacent and hypotenuse 4/5. We use the ratios between the sides to do some maths in trigonometry, and later on we'll show you how, but for now I just want to introduce you to these ratios, because the ratios have special names. Instead of always saying the ratio of opposite divided by hypotenuse of the angle, because it's always opposite of the angle, they gave this one a name. Its name is the sine ratio, but we abbreviate it SIN, and we always put theta afterwards because we're saying sine of the angle. And all that means is it's just another name for saying, let's do the opposite side of the angle divided by the hypotenuse. But instead of always saying, let's do the opposite of the angle divided by the hypotenuse, we gave it a name and we called it sine. So if I say the sine ratio, it means the opposite divided by the hypotenuse. Now we've got also, I should have done this a little bit more sensibly, sine. I could also do adjacent divided by hypotenuse, and this one has the name cosine, and we abbreviate it cos, and we always write cos of the angle, cos theta, equals adjacent over hypotenuse, and it's just means, if someone says use the cos ratio, it just means the ratio of sides that's adjacent divided by hypotenuse. And our last one is the tangent ratio, and I'm sure you can work out what its abbreviation is. It's tan theta. And the only pair of sides that we haven't compared yet is opposite and adjacent. Now normally we say in similar triangles that it doesn't matter which side goes on the top. These always get that order. People just decided, look, it could be hypotenuse over opposite, it could be opposite over hypotenuse, and they just decided let's always make it opposite over hypotenuse. So these are the three ratios that are the most important thing to learn about trigonometry, because we're going to use them to find out sides and angles. We'll learn that later. You must know these three ratios. You must remember that sine is opposite over hypotenuse. There's a memory aid to remember this. Some old hags can't always hide their old age, just fitting that in there. And you see SOH means sine opposite over hypotenuse. Can't always hide. C for cos, A and H for adjacent and hypotenuse. Their old age, tan is opposite over adjacent. So it's just an easier way to remember, so we learn those ratios. Much later on, we'll learn how to use, next lesson, we'll learn how to use these ratios. For now, I need you to be able to label the sides opposite, adjacent, and hypotenuse on any right-angled triangle. And I need you to know those three ratios and be able to write them exactly as I've written them in these three boxes. Know their names and which sides are involved.